Good morning. Let's look at the limit of a rational function in terms of a theorem. We know that if C is in the domain of R, where R is a rational function, then the limit as x goes to C of R of x is of course R of C, which says if C is in the domain of a rational function, then we can evaluate the limit functionally, namely by functional evaluation. So let's look at an example. So as an example, simple example, let's look at the limit as x goes to 1 of 3x minus 1 over x plus 2. The first question is 1 in the domain of this rational function? The answer is yes, of course, because the denominator is not 0, you can evaluate functionally. And in this case then, we evaluate the limit by evaluating functionally. So the answer is just 3 times 1 minus 1 over 1 plus 2. And whatever this number is, that's the limit. This is 2 over 3. So evaluating the limit of a rational function is quite simple if the number 1 is in the domain of the rational function, which it is here. Now what does this say about continuity? Well, what this also says is that a rational function is continuous at all points in its domain, because we can evaluate functionally. Since we evaluated this limit functionally, we know that R of x, defined this way, which is the same function, is continuous at 1, or sometimes we write at x equal 1, since the limit, as we just demonstrated, the limit as x goes to 1 of R of x exists. And we just showed this was equal to 2/3. Therefore, R is continuous at 1. In fact, R would be continuous at all numbers by this theorem, and this is a theorem, by the way. I just stated it without the fanfare, but this is a theorem. R would be continuous at all numbers but minus 2 by this theorem, because the only number not in the domain of R would be 2. How do we know that? Well, where are rational functions undefined? They're undefined where the denominator is 0. So if we set the denominator equal to 0 and solved, we of course get x equal minus 2. This says minus 2 is not in the domain of R. Okay, now this theorem doesn't say what happens if C is not in the domain of R. Rather, it just says what happens when C is in the domain of R, and that's important to note. So if C is in the domain of R, basically this theorem says R is continuous there, namely the limit can be evaluated by plugging in. Now if C is not in the domain, we don't know anything about the limit, okay? However, we know that the function would not be continuous there. The limit might in fact exist. At 2 or x equal 2. Okay? So, the limit of a rational function is, and not to oversimplify it, is somewhat easy or direct if C is in the domain. If C is not in the domain, well then we have to actually do more work. And we'll see that in a subsequent example. Thank you.